Hello and welcome to another math video for grade 11. In this video, I'm going to start section 2 of chapter 7, which is about trigonometric functions. What I want from you in this video and also on the other videos that will follow is that you need to remember everything you learned about trigonometry in grade 10. So you learned a great deal of trigonometry in grade 10. You learned about sine, cosine, tangent ratios. You learned about special angles in trigonometry, like 0, 30, 45, 60, 90, 120, 180, 270, 360. So those angles are special angles in trigonometry that you need to memorize the trig ratios for them. And also you learned about radian measure, how to convert between degrees and radian measures for angles. You learned some trigonometric identities, right? Like sine squared plus cosine squared of the same angle is always equal to 1, and so on. So I want you to remember those concepts from trigonometry in grade 10 so that you understand these concepts here in a much better and convenient way. So first we'll start off with the definition. A trigonometric function is a function that its rule is a trigonometric expression. So whenever you see a function that has some of those trig ratios like sine, cosine, tangent in them, you know that you're dealing with a trigonometric function. The fundamental three trigonometric functions are the following. So these are the basic parent trig functions. F of x equals sine x. Okay, so the input here is this angle for the sine function. The other fundamental trig function is cosine x. F of x equals cosine x. So this is the defining rule of this function. And the third one is f of x equals tangent of x. So these are the three basic fundamental parent trig functions. Just one thing you should be careful about here is that this angle x is considered to be radian. So these angles are measured as radian angles, not degrees. So whenever you're working in this section and also in the other sections, you need to change the button of your calculator to the radian measure, not degrees. So the main goal of this section is to graph these three trig ratios, trig functions. So we were going to see what is the graph of sine function, what is the graph of cosine function, and how does the graph of tangent looks like. So this is the main objective of this section here. But in order to do that one, we need to clear one more definition for ourselves, which is about periodic functions. Because the trig functions that we had here, they turn out to be periodic functions. So we need to know what is the definition of a periodic function. So we say a periodic function is a function that repeats exactly in regular intervals, called cycles. So a periodic function is a function that repeats exactly in regular intervals, called cycles. The smallest length of such cycles is called period of the function. So it is such a function that its values are repeating on regular intervals. So the function takes on the same values on different exactly exact same intervals that we call them cycles in this case. So here I gave you three examples of periodic functions for you to see. Let's look at the first one. See, the first one, the function starts here, goes like this, comes down, and then goes like this one, and then the same pattern repeats itself. After 2, again, you will see the same thing repeating. Right? The same thing. Okay, the same thing. And this goes on forever. This is an example of a periodic function. In this case, the cycle that it is repeating is this cycle. That's the first one. That's another one. That's another one, and so on. Okay, in this example, the period of this function is 2, right? So the length of the cycle is 2. This cycle has length 2. This one has length 2. All of them have length 2. So the period here is equal to 2, and that's the period of this function. The other one is something similar, but this time if you start from 0, so the function goes like this, comes up and goes down, and then exactly the same thing happens, the same pattern follows, right? But here, because of the space, we don't have the other parts of the graph, but the same thing will happen. Even if you look at the left side, the same thing is repeating, right? So this is one cycle, and then the same thing happens. So in this particular example, the cycle is from here to here, which turns out to be 6. So the period of this function is 6. So let's write it down here. Period equals 6. The other example is something similar to that one. So the function starts like this, comes down, and then goes up. So that's one cycle. And the same exact pattern repeats itself. Okay? The same thing repeats forever. So these are examples of periodic functions. In the last case, the period of the function, it seems to be 6. Maybe a little bit more than 6, but let's take it to be 6. So here in this case, period is equal to 6. I just want you to notice here that the periodic functions are very special kinds of functions because they have very special shape, they have very special graph, they have some parts that are repeating exactly on the same intervals. So they're very, very special kinds of functions. In fact, most of the functions are not periodic. So let's see some examples of not periodic functions. Well, this function is not periodic. It's supposed to be a parabola. Well, the values are just keep on increasing forever on that side. The same thing happens on the other left side. So this is not a periodic function. Another example could be something like this. This one is not periodic because although it is oscillating, but the oscillation here is damped. So it's the intervals are getting, on the intervals it's getting closer and closer to the x-axis. So it's a damped oscillation. So this function is not periodic. The values are not repeating themselves. So that's pretty much everything I wanted to tell you about periodic functions. Let's see. Yes, let's start the main objective of this section, which is about graphing those trig functions. So we start with the graph of sine function. So f of x equals sine of x. We're going to see what is the shape of this function, sine of x. The method that I'm going to use here to graph this function is point plotting. So I'm going to use point plotting to graph this function. If you remember, point plotting is the same thing as like a table of values. So you have a table like this. Here you put the input, and here you put the outputs. You start giving values for x, and then you calculate the corresponding values for sine x, and then you got the pair of points, and then you find the points on the coordinate plane, and then connect them with the smooth curve. So that's the method of point plotting that I'm going to use here. But since I'm working with sine function here, I'm going to choose the inputs wisely. Again, I'm going to refer you to grade 10 trigonometry for the special angles. So here I'm going to put the special angles in radian measures, right? So we start with 0. After 0, one of the special angles that we have is pi over 6, then pi over 4, pi over 3, right? Then pi over 2, and then let's try pi, 3 pi over 2, and then 2 pi. So here you can use a calculator if you have forgotten these special angles. If x is 0, sine of x will be 0. If x is pi over 6, sine of x will be 0.5. If it's pi over 4, its sine is root 2 divided by 2. If it's pi over 3, is root 3 divided by 2. At pi over 2, sine becomes 1. At pi, sine becomes 0. At 3 pi over 2, it becomes negative 1. And at 2 pi, sine becomes 0. Okay, so now let's find these points, these pair of points, and then connect them with the smooth curve. So 0, 0 will be here. Pi over 6, 0.5. So if you here I just in this shape I just put these angles at pi over 2 pi, 3 pi over 2, 2 pi, and those will be enough for us to find the approximate shape of the graph of the sine function. But if you want, you can fill out these ones in the middle, right? So pi over 6 will be somewhere maybe about here, and its corresponding y value is 0.5, so it's here, and this y value will be about here. So maybe this point here, and then for pi over 4, maybe it's a little bit higher. For pi over 3, it becomes a little bit higher. At pi over 2, it becomes exactly 1. Right, so at pi over 2, it's 1. Then at pi, it becomes 0. So that's the pi point. At 3 pi over 2 is negative 1. It goes down. At 2 pi comes back to 0 again. So this is the graph of sine function in one cycle, from 0 to 2 pi. After 2 pi, the same exact pattern repeats itself. So the function goes up, comes down, and so on. And on the left side, the same thing happens. You can try with negative angles here, and you will get the same exact shape on the other side that is repeating itself on cycles of length 2 pi. So this is the graph of sine function. As you notice here, the domain of this function is all the real numbers. The graph stretches on all the real numbers on the x-axis, and that's how you find domain of any functions, right? But the range of this function is between negative 1 and 1. So the maximum value that the function gets is 1, and the minimum value that the function obtains is negative 1. So the function is trapped between negative 1 and 1, and that's how you find the range of this function. So these are the important characteristics of sine function. Domain is everything, all the real numbers. Range is between negative 1 and 1. And also that this function is periodic because the shape will repeat itself. I'll show you in the next slide. As you see here, I put a little bit more, I included a little bit more parts of the graph of sine function. It goes from 0 to pi half, which is 1, and then at pi is 0, at 3 pi over 2 is negative 1, at 2 pi is 0, and again the same exact pattern repeats itself. The same thing goes on forever. On the left side, we'll have the same situation. So this function is periodic with period of 2 pi, because that's the length of the cycle. From 0 to 2 pi, we will get a full, complete one cycle of the sine function. Next trig function is cosine function. So we're going to do the same thing. We're going to graph f of x equals cosine x. F of x equals cosine of x. Again, we will do the same method for graphing this function, which is point plotting. So input and output is cosine function. I'm going to stick to the very special angles, which are 0, and then pi half, and then pi, and then 2 pi. Oh, sorry, after pi we have 3 pi half, 3 pi over 2, and then we have 2 pi. Again, you can use a calculator, but I strongly recommend you to memorize the trig ratios for these special angles. So if x is 0, cosine of 0 is 1. Cosine of pi half will be 0. Cosine of pi is negative 1. Cosine of 3 pi half is 0. Cosine of 2 pi is 1 again. So if you plot these points on the coordinate plane, 0 and 1, the first point right over here. Pi half 0 will be this point. Pi negative 1 is here. So this cosine function obtains its minimum at pi. At 3 pi half, it becomes 0. So this point is 3 pi half. And it comes back up again. This point will be 2 pi. So this point here is actually 3 pi over 2. And 2 pi is right over here. And that will show us one complete cycle for a cosine function. It starts from here, goes back up to 1 again. And that's one cycle for cosine function. And this cycle repeats itself exactly the same as this way. So it repeats itself. And on the left side, the same thing happens. Again, just like a sine function, as you see, domain of this function is all the real numbers. It stretches all the way from negative infinity to positive infinity on the x-axis. And its range varies from negative 1 to 1. So the function is trapped between negative 1 and 1. The values of this function is between negative 1 and 1. Here I have I've given you the more cycles of this function cosine. Again, at 0 is 1, okay, and that's one complete cycle. Comes from here and goes up here, and then the same exact pattern repeats itself after this one. So as you see, the period of this function again is 2 pi, because that's one complete cycle, right? So period is 2 pi here in this example. So period of this function is also 2 pi. So that's it for this video. I'm going to stop here. In the next videos, I will continue with tangent function and some more properties of these trig functions.